Welcome. In this video, we're going to be discussing how to take the idea of writing equations of lines to the next level. So in the example number 1 here, we see that we would like to find the value of y. So we see down here there's a y missing from this coordinate. And we want to find the value of y so that the line going through 8, -2 and -8, 6. So here's 8, -2, here's -8, 6. So this line, we want to have a line that goes through those 2 points, so that's the blue line, is perpendicular to the line that passes through this said point, so we don't know where that is, and this point. So -3, -8 is down here. So this line is perpendicular, and it rolls through the blue line at 90 degrees. So let's put that in the picture. Now, I know that if I have a line, right, y equals mx plus b, I know that my y value and my x value, if I were to create a table of values, is an infinite collection of the points on said line. So if I knew the equation of the green line, I could substitute in 3 into the value of x and solve for y. So that's what we're going to do. 1, we're going to calculate the slope from the blue line. 2, we're going to use the opposite reciprocal of that slope to calculate the slope of the green line. Right? So this is for the blue line, and then this is for the green line. Once we have the slope for the green line, we already have a point, and we will use our point slope formula to write the equation of the green line. Once we're done with the equation, we can then substitute in the value of x and solve for y. So let's go ahead and get that process done. Okay, so first I took my 8, -2 and my -8, 6, put that into the slope formula, reduce it down to 1/2. And so my slope of my green line is going to be the opposite reciprocal of that, or 2/1. So let's see how this all shakes out. I have a slope of 2 and a point -3, -8 is my given point on said green line. So we have our y minus y1 gives us y plus 8, slope of 2 times x minus x1, which is x plus 3. After I do the distribution and clean this all up, we have our equation of the green line. Now all we need to do is substitute in the 3 into the x value and solve for y. And so as you see up here, I substituted in 3 for my x value to get 6 minus 2, which is 4. So y equals 4 when x is 3. And if we were to plot that point on our graph, 3, 4 would be right up there. That seems to be a reasonable space to where that line was going. And we could also substitute that in the Desmos using said equation to make sure that 3, 4 is actually on the line. Let's try another one. Okay, so the second verse, same as the first, right? Find the value of x this time, right here. So it looks like we notice we're missing an x, so that the line through this point and 4, -3 is perpendicular to the line that passes through 1, 6, and 7, -2. So 7, -2 is right here, 1, 6 is right here. That's our blue line, right? Sort of like I would call this the given line. And then our value of 4, -3 is right here. So if that's perpendicular, kind of just ballpark it here, put a little right angle mark there to indicate perpendicular. And so again, here we go. We're going to find the slope of this line. We're going to get the opposite reciprocal, which will give us the slope of the perpendicular line. We're going to use our point slope formula with the given point to write the equation of the line that's perpendicular. And then we're going to finish up with substituting in the value of y and solving for x. So here we go. So let's see how it worked out. First, I took my 2 given points and I calculated the slope. So -2 minus 6 over 7 minus 1 gives us a -8 over 6, or -4/3, which makes sense. This is a negative slope, which means we're going down 1, 2, 3, 4, right 1, 2, 3, and back on the line. So that checks out good. Now our given point was 4, -3. That was one of the points on the green line. We don't truly know this other point just yet. So we take our Negative 4/3, opposite reciprocal, gives us positive 3/4 because it's perpendicular. We're using the opposite reciprocal. And our point slope formula, so y minus y1 is y minus negative 3, y plus 3. 3/4 is the slope times x minus x1, which is x minus 4. After we distribute, clean everything up, we get a final equation of y equals 3/4 x minus 6. Now we're going to substitute in the value of 6 into y and solve for x. So essentially, 6 is going to go right here. So after substituting 6 in for y, doing all the arithmetic, taking care of the point when I get to 3/4 x. To undo that 3/4, I'm dividing by 3/4, which is this equivalent to multiplying by 4/3, the reciprocal, right? To divide a fraction by a fraction, you multiply by its reciprocal. So I multiply by 4/3 on both sides, and 4/3 times 12 gives us 16. And if you look at that 16, right, so if this is 8 right here, sort of a similar distance would put us about here, and to go up about 6 would be right here. And all I'm saying is if we extended that green line to hit that point of 16 comma 6, I think we are in good shape. So our final answer, the value of x, is 16. Good to go. As we move along into the next section, 3.6, we're talking about distance, right? The definition of distance between a point and a line. So we have a point right here, and we have this line right here. How do we measure the distance? Well, we don't measure it at a diagonal fashion. We measure it perpendicularly. We have to go from this point to this line at 90 degrees. So that said distance is between this point and this point is always going to be measured at being a perpendicular line. So in our notes, we will define the distance from a point to from a line to a point not on the line as the length of the segment that is perpendicular, right? Perpendicular to the line from the point. And the distance between any 2 points is called the distance formula, right? So we've seen this before, but I just want to kind of go over one thing. So you may want to press pause and copy all this into your notes, then press unpause and sort of take a walk through the mathematics with me. So press pause now and copy everything that you see here. Okay, so over here, I'm going to start with the triangle. I see that I have a right triangle here with sides A, B, and C as the hypotenuse. And we know that the Pythagorean theorem says that a squared plus b squared equals c squared. That this leg squared added to this leg squared will give us the hypotenuse squared. And so what I'm really trying to focus on is this distance between the 2 white points. That's what the distance formula is giving us. We know that we could easily measure horizontal distances by taking the differences of the x values. So if we start here at this point, call this x1, y1, and we move to the right, what we're changing is the x value. So I'm going to call this x2, y1. Notice the y values are the same because it's the same height. And if I go directly above x1, y1, I haven't changed the x values, so this is still x1. But we're at a higher y value, so we call this y2. The length of a, right, because we want to take a and square it, the length of a is the difference of the x values. That is x2 minus x1. So if I want to measure horizontally, really horizontally, it's just changing x values. So a is x2 minus x1. So a squared is x2 minus x1 all squared. The vertical differences can always be measured by just subtracting the difference of the y values. And that would be y2 minus y1. So the length of b is y2 minus y1. So b squared is y2 minus y1 squared. Well, we don't want the measure of the hypotenuse. We want the measure, we don't want the hypotenuse squared. We want the measure of the hypotenuse itself. So the square root of c squared is c, and everything here just comes down. So the distance formula, as you see, is really just the Pythagorean theorem in coordinate notation. Very cool. Again, we want to have all of this in our notes. For this problem, you're going to want to skip ahead, I believe, a page or so in your notes and look for this equation and said point. Then the first thing we're going to do is graph said equation. The issue you'll notice is that it has a y-intercept of 6 and we're going to top out over here. So what we're going to do is we're going to change the scale, and we're going to count by 2's on both the x and the y scale. So go ahead and graph that line. As you'll notice, I went up 6, right? Plotted my y-intercept. My slope says to go down 1, right 3, down 1, right 3, down 1, right 3, down 1, right 3, or down 2, right 6, down 2, right 6, and I drew a nice straight line. Then we have 0.22, so we're just going to go ahead and plot our 0.22, and the instructions ask us to do something very intense. We're going to graph each equation. Which equation? We're going to graph this equation, and we're going to construct the line perpendicular and find the distance from the point to the line. Which point? This point to this line. But remember, if we're going to measure, we're going to measure perpendicularly. So first, I have to get some sort of perpendicular line. So I'm just going to kind of ballpark that, right? Just going to kind of ballpark it like this. And I think that's roughly 90 degrees. So it's okay if it's not perfect. I'm just trying to get a line so that I have a rough idea. And I'm going to call this point A. So A is at 2, 2. I'm looking to find the distance from A to B. B is going to be this point of intersection. But first, I need to figure out what that point is, and that's going to require a little something extra. First and foremost, let's find the equation of that line. We already know how to do that. So I've taken the liberty. I have the blue line, slope of -1/3, perpendicular, opposite reciprocal, +3, given point, put all that in my point-slope formula, busted out the equation, y equals 3x minus 4. I have my -4 right here, and now I just want to know, is that in line with the rest of my existing line? So I'm just going to kind of connect. I have, again, this guaranteed point right here. I'm saying that this is my y-intercept on my newly constructed equation. So I'm going to connect those, and it looks like my by hand line and that line seem pretty much in line. So I'm feeling pretty good about the equation and about my originally hand sketched line. Now what we're looking to do is find this point B, and that is the point of intersection, right? The point of intersection between the two lines. How can we figure out what the coordinates are without just counting on a grid? We're going to use systems of equations, right? So back in Algebra 1, we learned that we can solve systems by substitution. So in algebra, or in geometry rather, we learned that if A is equal to B, then I can substitute in B anywhere that I see A. Now here's what I know. Y equals -1/3 x plus 6, and y equals -3x minus 4. So if y is equal to both of these statements, then the statements themselves must be equal. -1/3 x plus 6 must be equal to 3x minus 4. And now I'm going to solve for x. Again, at any time, press pause and try to catch up. But I have first taken the liberty of taking the 3 and distributing across this. And you say, where does the 3 come from? Well, I had a fraction of 1/3, and I just didn't feel like dealing with the fraction. So the first thing I did is I multiplied each term by 3 to cancel out the 1/3. So 3 times -1/3 is -1, plus 18 equals 9x minus 12. I solved, I got x equals 3. Then I just grabbed, right? It doesn't matter, you can grab either equation. I grabbed the original equation, and I substituted in the x value of 3 into my value of x over here, and I solved for y. So I get y of 5. So that means B over here, remember B, point of intersection, is 3 is 5. So I've solved the system of equations. So now I have my 2 points. A, which was given at the beginning, is 2, 2, and now B is 3, 5. So I'm going to use the distance formula to find what? Remember, they asked us to find the distance between the point that wasn't on the line and the line. The reason why we had to do all of this is because I have to measure perpendicularly, right? So I needed that perpendicular line, found the equation of the perpendicular line, solved for the system of equations to figure out the point of intersection. Now I have 2 points. Now I can go ahead and find the distance. All right. And so our final act, we substitute these into the distance formula. Difference of the x's, which is 1. Difference of the y's, which is 3. Square both of those, I get 10. Now just for the record, we prefer this to be our final answer, right? This is my final answer. That's the distance between said point 2, 2 and the line, right? So the distance between A to B, which was 3, 5. And by the way, 3, 5, right? This was 2 originally. This was 4, so 3 over to here. This was 6 right there. So that seems like 5. So that also verified that point, right? But what is the square root of 10? The square root of 10 is approximately 3.2. And all I'm saying is each box, left to right or up and down, counts for 2. So as I look at this, this is like, more than a full box and then a kind of a half of a box there. So 2, 3 and change. This makes sense to me. So this is our final answer, and everything seems to check out. Okay, so first let's run through this again. You're actually going to go to a preceding point. This originally said y equals 2x minus 2. We're going to change that equation to 2x minus 1 with an original point of negative 3, 3. And again, same thing. We're going to plot, calculate, yada, yada, yada. Let's go through a systems check here. First, we're going to draw both lines. One of those lines is a sketch, right? This I can plot perfectly. The perpendicular line, wherever it is going to be sort of a sketch, starting from this point through this line perpendicularly. Then we are going to, using the slope of this line, identify the slope of the perpendicular line, use this point, construct the equation of the second line. Then we're going to take those two equations and we're going to solve the system to obtain a second point, which is the point of intersection, and then we're going to calculate the distance between said point of the system and the original point, and that will be our final answer. So let's get cracking. And once again, maybe press pause and try to work through as much of this as you can on your own before you walk through it with me. Press pause now and give it a shot. Okay, so the first thing I did is I looked at my given blue line. Equation was given as 2x minus 1. So my slope of the blue line is 2. For a line that's perpendicular, it's going to be the opposite reciprocal of 2, which is negative 1/2. So I take that negative 1/2 and the given point, and I put that in my point slope formula. Y minus 3, which is my y minus y1, is the negative 1/2 slope times x minus a negative 3, which is x plus 3. After I do all the algebra there, I get y minus 3 equals negative 1/2 x minus 3/2. When I add the 3 to this side, adding 3 is like adding 6/2. So I get y equals negative 1/2 plus 3x. Notice there are no decimals. Okay, no decimals. Learn to work with the fractions. Now what? Now I have my newly constructed equation, the original equation. So if y equals negative 2x minus 1, and the same y value equals, right, negative 1/2 x plus 3/2, then I can set these two by substitution to each other. So 2x minus 1 equals negative 1/2 x plus 3/2. First thing I did is I multiplied by 2 because I had a couple of fractions here, so I just sort of obliterate those by multiplying by 2. So 2 times 2x is 4x, 2 times negative 1 is negative 2. 2 times negative 1/2 x is negative 1, and 2 times 3/2 is 3. Now I add the 1x to both sides, I add the 2 to both sides, 5x equals 5, x equals 1. So of this point right here, this intersection, the x value is 1. Now I take that value and I substitute the x into here. I could have put it in here, but this is a pain in the neck to work with, so I put the value of 1 here. So 2 times x minus 1, so 2 times the value of 1 is 2 minus 1 is 1. So b is 1, 1. And now I'm going to take negative 3, 3 and 1, 1, and I'm going to find said distance, right? So I'm looking for this distance. Now, just for the record, it looks like it's about 1, 2, 3, 4-ish units. So we should get an answer. It's going to probably give me an ugly square root, but it should be around 4. And so here you have it. The distance between AB is 1 minus a negative 3, which is 1 plus 3 all squared, which is 4 squared is 16. And then 1 minus 3 is negative 2 squared is positive 4. Impossible to have a negative distance at this point. 16 plus 4 is the square root of 20. And the square root of 20, just for argument's sake, is approximately 4.5. So we said it was around 4-ish. It is. There you go. So you should be all set. Hopefully this was helpful. See you next class.